My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications second semester subject Advanced Computer Networks as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define bandwidth. Bandwidth is the maximum amount of data that can be sent over a network in a given time. It is usually measured in bits per second, BPS, such as Mbps, megabits per second, or Gbps, gigabits per second. Easy example. Think of bandwidth like a highway. The more lanes the highway has, the more cars, data, can travel at the same time. So, a higher bandwidth means more data can flow through the network faster. For example, if you have an internet connection with 100 megabits per second bandwidth, it means you can download or stream up to 100 million bits of data per second. Why it's important? Higher bandwidth is equal to faster internet, better video calls, smoother gaming. Lower bandwidth is equal to slow downloads, buffering, and delays. Tip to remember. Bandwidth is equal to data highway speed. The bigger the road, the more data travels easily and quickly. Next important short question is: 2. Define latency. Latency means the delay or time taken for data to travel from the sender to the receiver across a network. It is usually measured in milliseconds, ms. Easy example. Imagine you are talking to a friend on a video call. If you say hello and your friend hears it after 2 seconds, that delay is called latency. Lower latency means the response is faster, and higher latency means there is a longer delay. Types of activities affected by latency. Online gaming needs low latency for quick reactions. Video calls, high latency causes lags or delays. Web browsing, lower latency gives faster loading. Even if you have high bandwidth, high latency can make your internet feel slow. Tip to remember. Latency is equal to waiting time for data. Less waiting is equal to faster and smoother communication. So, for best network performance, we want low latency. Next important short question is: 3. Define high-speed networks. High-speed networks are computer networks that can transfer large amounts of data quickly. They have high bandwidth and low latency, making them perfect for activities that need fast and smooth data flow. Easy example. Think of a bullet train compared to a normal train. A bullet train carries passengers faster, just like a high-speed network carries data faster. For example, fiber optic internet is a high-speed network. It lets you download movies in seconds, stream HD videos without buffering, play online games smoothly. Where it's used: data centers for fast communication between servers, multimedia streaming platforms like YouTube and Netflix, cloud computing for quick data access and backups, video conferencing and online classes. Tip to remember. High-speed network is equal to fast, smooth, and efficient data transfer. It's like having a super-fast road for your internet. Everything gets done quicker and better. Next important short question is: 4. Network-centric view. A network-centric view means that the network is the center of everything. All devices, applications, and users are connected through it and depend on it for communication and services. Easy example. Imagine a railway network where trains, data, move between stations, devices. Without the tracks, network, nothing moves. Similarly, in a network-centric system, the network acts as the backbone that connects and controls all activities. Why it's important? In a network-centric view, focus is on data sharing, communication, and coordination through the network. This view is used in smart cities, defense systems, and cloud computing, where multiple systems work together through one strong network. Real example. In online banking, everything, the app, the database, and the user connects through the network. If the network is down, the service stops. Tip to remember. Network-centric view is equal to network is the heart. Everything runs smoothly because the network connects all parts. Next important short question is 5. Define error detection. Error detection is the process of finding mistakes in data that is sent over a network. When data travels from one device to another, sometimes it gets changed or damaged due to noise or signal problems. Error detection helps us check if the data is correct or not. Easy example. Imagine you send a WhatsApp message saying hello, but your friend receives "Hezo." This is a data error. Error detection helps the system find out that something went wrong during transmission. How it works? Before sending data, the sender adds a special checking code, like a checksum or parity bit. When the receiver gets the data, it also checks the code. If the code matches, the data is correct. If it doesn't match, an error is detected. Tip to remember. Error detection is equal to spotting mistakes in data. It makes sure the information sent over the network is safe and accurate. Next important short question is 6. Reliable transmission. Reliable transmission means making sure that the data sent over a network reaches the receiver correctly and completely, without any loss, damage, or errors. Easy example. Imagine you are sending a parcel to your friend. You want it to reach safely, without being lost or broken. If the parcel is damaged, you want it to be resent. Similarly, in computer networks, reliable transmission ensures that every message or file reaches the destination just as it was sent. How it works? Reliable transmission uses acknowledgements, ACKs. The receiver sends a message back to say, "I got it." Resending. If the sender doesn't get an ACK, it will resend the data. Checks for errors, using techniques like error detection to make sure the data is correct. Example in real life. TCP, Transmission Control Protocol, is used for reliable transmission in the internet, like when you download files or send emails. Tip to remember. Reliable transmission is equal to safe delivery of data, no loss. Next. Unit 1. Long questions. First important long question is: write briefly about network architecture. Network architecture is the design and structure of how computers, devices, and systems are connected in a network. It tells us how data flows, how devices communicate, and what rules and protocols are used. It's like the blueprint of a building. It shows how each room, device, is connected and how people, data, move between them. Types of network architecture. 1. Peer-to-peer, P2P architecture. All computers are equal. Each one can act as both a client and a server. Example, file sharing between two laptops using Bluetooth or Wi-Fi. 2. Client-server architecture. One central server provides services, like data, files, to multiple clients, users or devices. Example, in a bank, the main server stores customer details, and staff computers, clients, access this data. Key components in network architecture: devices, computers, servers, routers, switches, etc. Communication links, wired or wireless connections like Ethernet cables or Wi-Fi. Protocols, rules that decide how data is sent and received like TCP/IP. Topology, the layout or shape of the network like star, ring or bus. Why network architecture is important: helps in easy communication between devices, makes it simple to add new devices or users, improves security by controlling how and who can access data, ensures efficient data transfer without confusion or loss. Real-life example: in a school, the server stores exam results. Teachers' computers, clients access the server to enter or check marks. All are connected through a network, which is designed using client-server architecture. Tip to remember: network architecture is equal to plan of how devices talk to each other. Just like a city map shows roads and buildings, network architecture shows data roads and device buildings in the digital world. Next important long question is: to write briefly about network performance. Network performance means how well a computer network works. It tells us how fast, reliable, and smooth the network is when sending and receiving data. Good network performance is important for things like browsing the internet, watching videos, online classes, or playing games. Key factors of network performance. 1. Bandwidth. This is the maximum data that can be sent in 1 second. More bandwidth is equal to faster data transfer. 2. Latency. This is the delay in data reaching its destination. High latency is equal to slow response, lag. 3. Throughput. This is the actual amount of data successfully sent in a second. It's usually less than bandwidth due to errors or congestion. 4. Error rate. The number of errors that occur while sending data. Fewer errors is equal to better performance. 5. Jitter. The variation in delay during data transfer. High jitter is equal to choppy audio-video, bad for calls or streaming. Example: imagine you are watching a movie online, streaming. If the bandwidth is high, the movie loads fast. If the latency is low, you get real-time streaming. If there is no jitter or errors, the video plays smoothly without pauses. But if the network has low performance, the movie will buffer, pause, or lose quality. How to improve network performance? Use faster internet plans. Reduce the number of devices connected at the same time. Use wired connections, like Ethernet, instead of weak Wi-Fi. Upgrade your router or modem. Use quality of service, QoS, settings to prioritize important tasks like video calls. Tip to remember: network performance is equal to how fast, smooth, and reliable your internet is. Just like a good road gives you a smooth ride, a high-performance network gives you a fast and smooth digital experience. Next important long question is: 3. Explain about Ethernet. Ethernet is one of the most common technologies used in computer networks to connect devices like computers, printers, and routers. It allows these devices to share data quickly and reliably using wires, usually Ethernet cables. What is Ethernet? Ethernet is a wired networking technology that connects devices in a local area network, LAN. It follows a set of rules called the Ethernet protocol, which tells devices how to talk to each other and send or receive data. How does Ethernet work? Devices are connected using Ethernet cables, like Cat5 or Cat6 cables. These cables plug into devices using Ethernet ports, looks like a bigger version of a phone jack. All the devices are connected to a switch or router which manages the network traffic. When one device sends data, it goes through the cable, passes through the switch, and reaches the correct device. Example: in a computer lab, all computers are connected using Ethernet cables to a central network switch. Students can share files, access the internet, or print documents through the network easily. Advantages of Ethernet: 1. Fast speeds up to 1 gigabit per second or more, much faster than many wireless connections. 2. Reliable connection, stable and consistent with very little interference. 3. Secure, since it's wired, it's harder for outsiders to access. 4. Low latency, great for online gaming, video calls, and big downloads. Limitations: 1. Limited mobility, devices must stay near the cable. 2. Cabling required, can look messy with too many wires. 3. Harder to expand, adding new devices might require extra cabling. Tip to remember: Ethernet is equal to wired, fast, and reliable network. It's like a direct road between two houses, making sure your messages, data, travel quickly without traffic or delay. Ethernet is still widely used today in homes, schools, and offices for stable and fast internet connections. Next important long question is: 4. Explain about multiple access networks. Multiple access networks are types of network systems where multiple devices share the same communication channel or medium, like a radio frequency or a cable. In these networks, many users or devices can send and receive data over the same network link, but to avoid confusion, there are rules that decide when and how each device can send its data. How does it work? In a multiple access network, multiple devices, like computers, phones, or printers, are connected to a shared medium. The challenge is ensuring that these devices don't interfere with each other while transmitting data. This is where different multiple access techniques come in, which help manage how devices use the network. Types of multiple access techniques. 1. FDMA, Frequency Division Multiple Access. Each device is assigned a unique frequency band. Example: in mobile networks, different channels are assigned to different users so they don't interfere with each other. 2. TDMA, Time Division Multiple Access. Devices share the same frequency but take turns sending data at different time slots. Example: think of a group of friends passing a ball. Each one gets the ball at different times, without anyone fighting over it. 3. CDMA, Code Division Multiple Access. Devices transmit at the same time but use different codes to separate their data. Example: imagine multiple people speaking at the same time, but everyone is using a different language code that others can't understand. Example of multiple access networks. A good example of a multiple access network is your Wi-Fi network at home. Multiple devices, laptops, phones, printers, all connect to the same router and share the internet, but they follow the rules of Wi-Fi protocols to avoid data collision. Why it's important? Multiple access allows efficient sharing of resources. It ensures fair distribution of bandwidth and avoids interference. It is widely used in cellular networks, Wi-Fi, and satellite communications. Tip to remember: multiple access networks is equal to many devices, one channel. It's like sharing a classroom where everyone gets a turn to speak without interrupting others. Next important long question is: 5. Explain briefly about overlay networks. An overlay network is a virtual network built on top of an existing physical network. It allows devices to connect with each other in a different way than the underlying physical network. In other words, it overlays a new network structure or layer over an existing one using the resources and infrastructure already in place. How does it work? In an overlay network, the actual data transmission happens on top of another network. It uses the existing physical network, like the internet or local network, to create new connections between devices that may not be directly connected in the physical network. This new layer can provide extra functionality, such as security, privacy, better performance, or efficient communication, without changing the underlying network. Example of overlay networks. 1. Virtual private networks, VPNs. A VPN creates an overlay network by establishing secure connections over the internet, the underlying physical network. Even though the data travels through the regular internet, it's encrypted and secure through the VPN overlay. Example, when you use a VPN, you can access websites in another country by pretending you are there, even though you are physically located in a different place. 2. Peer-to-peer, P2P, networks. In P2P networks like BitTorrent, devices form an overlay network for file sharing, even though they are all part of the broader internet. Each peer directly connects to other peers to share files in a decentralized way, bypassing traditional server-client communication. 3. Content delivery networks, CDNs. CDNs like Akamai use overlay networks to improve the speed and reliability of delivering web content by placing cached data on multiple servers located closer to end users. Why are overlay networks important? 1. Enhanced security. Overlay networks can be used to create secure channels over insecure networks. 2. Better performance. They can reduce latency and improve network speed by bypassing congested routes. 3. Flexibility. They allow innovative applications and features without changing the underlying infrastructure. Tip to remember. Overlay networks is equal to virtual networks on top of real networks. It's like putting a new layer over an old one to make it faster, safer, or more efficient. Next important long question is 6. Explain about peer-to-peer networks. A peer-to-peer, P2P, network is a type of network where all devices, called peers, are equal. In this network, every device can act as both a client and a server. Unlike client-server networks, where the server provides services and clients consume them, in P2P, each device can share resources, send requests, and receive data. How does P2P work? In a P2P network, there is no central server controlling everything. Each peer can directly connect with other peers to exchange data. When one device wants to send a file, it doesn't go through a central server. Instead, it connects directly to the recipient. Example. Imagine you are sharing files with a friend. In a P2P network, both your computer and your friend's computer are equal participants. You both share files directly with each other without needing a middle server. Files can come from multiple sources, other peers, making the system faster and more reliable. Popular examples of P2P networks. 1. File sharing, BitTorrent. BitTorrent allows users to download files by connecting directly to others who have the same file. Instead of downloading the entire file from one server, the file is broken into smaller pieces and downloaded from multiple peers. 2. Media sharing, Napster, old example. Napster was one of the first P2P networks, allowing users to share music directly from their devices. 3. Blockchain and cryptocurrency, Bitcoin. Bitcoin operates using a P2P network, where users, peers, verify and send transactions directly without relying on a central authority like a bank. Why P2P networks are important? 1. Decentralization. There's no single point of failure. If one device goes offline, the others keep working. 2. Cost-effective. No need for expensive central servers, which lowers costs. 3. Scalability. P2P networks can grow easily by adding more peers without major changes to the network. 4. Speed. Files and data are transferred from multiple sources, often making downloads faster. Tip to remember. Peer-to-peer is equal to equal devices sharing directly. It's like a group of friends sharing files with each other without needing a teacher, server to control everything. Next important long question is 7. Content distribution networks. A content distribution network, CDN, is a system of servers that work together to deliver web content like websites, videos, and images to users in a faster and more efficient way. The main goal of a CDN is to reduce latency, delay, and improve load times for users, no matter where they are located. How does a CDN work? In a CDN, content is copied and stored on multiple servers that are spread across different geographic locations. These servers are called edge servers. When a user requests a website or video, the CDN ensures that the content is delivered from the server closest to the user, rather than from a single central server. This local delivery speeds up access to the content and reduces delays. Example. Imagine you are watching a video on YouTube. You might be in India, but the YouTube server could be in the USA. Without a CDN, the video data has to travel a long distance, causing buffering or delays. With a CDN, YouTube has multiple servers across the world. The video is delivered from the server closest to you, perhaps in Asia, reducing load time and improving the viewing experience. Key benefits of CDNs. 1. Faster load times. By serving content from nearby servers, users experience quicker access to websites and media files. 2. Reduced latency. Content reaches users faster, with less delay, making browsing, streaming, and gaming smoother. 3. Improved reliability. Since the content is distributed across multiple servers, if one server fails, the CDN can route traffic to other available servers. 4. Scalability. CDNs can easily handle high traffic volumes without slowing down, which is great for events like live streams or product launches. 5. Security. CDNs help with protecting websites from attacks like DDoS, distributed denial of service, by spreading traffic across multiple servers. Real-life example. Popular websites like Amazon, Netflix, and Facebook use CDNs to deliver content quickly to users worldwide. Netflix, for instance, uses a CDN to stream videos to millions of users without buffering, ensuring a smooth experience. Tip to remember. CDN is equal to faster web experience for everyone. It's like having local stores in many places instead of traveling far to a single shop to get what you need. Next important long question is 8. Client-server networks. A client-server network is a type of network where there are two main types of devices, clients and servers. In this network, the client requests services or resources, and the server provides those services. This type of network is one of the most common and is used in many online applications and systems. How does it work? In a client-server network, the client is a device, like a computer, smartphone, or tablet, that requests data or services from the server. The server is a powerful computer or system that provides the requested services, such as files, data, or access to applications. When you use a web browser to access a website, your computer acts as a client. The website's web server responds by sending the website's data back to your browser. Example of client-server network. Let's take the example of email. Email client. When you use an email app like Gmail or Outlook, your device, the client, connects to the email server. Email server. The server stores all the emails and responds by sending you the requested emails or information. If you send an email, your client, device, sends it to the email server, which then sends it to the recipient's server. Key features of client-server networks. 1. Centralized control. The server controls access and management of resources, example, data, files, applications. It helps organize and secure the network. 2. Shared resources. Clients can access shared resources like files, printers, or databases managed by the server. 3. Efficient communication. Servers handle multiple requests from clients and provide a central point of contact for all devices in the network. 4. Security and maintenance. Since all data and services are managed by servers, security, updates, and backups are done centrally, ensuring better data protection. Real-life example. When you use online banking, your device, client, connects to the bank's server to access account information, check balance, or transfer money. The server stores all the data and processes your requests. Tip to remember. Client server is equal to request and response. It's like a customer, client, asking for something from a shopkeeper, server, who then delivers what's asked for. The server is the main source of all services, and the clients interact with it to get what they need. Next important long question is 9. Write briefly about delay-tolerant networks. Delay-tolerant networks, DTNs, are special types of networks designed to deal with long delays or unreliable communication between devices. Unlike traditional networks, where devices are expected to communicate in real time, DTNs are built for situations where there might be delays in the transmission of data or when devices may not always be connected to each other. In a DTN, the data is stored temporarily and forwarded when possible. This helps to overcome issues like network disconnections, long travel times, or poor connectivity. It's like sending a letter through a postal system where there's no guarantee it will reach its destination immediately, but it will eventually get there when the path is clear. How does a delay-tolerant network work? In a DTN, when data is sent from a source device to a destination, if the two devices can't directly communicate, the data is stored temporarily on intermediate devices, called routers or nodes. Once a connection becomes available, the data is forwarded to the next node or destination. This method of store and forward helps ensure that data reaches its destination eventually, even if there are network delays or intermittent connections. Example of delay-tolerant networks. 1. Space communications. Communication between Earth and spacecraft in space uses a delay-tolerant network because the spacecraft is often far away from Earth and faces long communication delays. Data from the spacecraft is stored and forwarded when a link to Earth is available. 2. Remote areas. In remote or rural areas with limited internet connectivity, DTNs can be used to deliver messages when devices, like mobile phones, come in range of each other. Messages are stored and sent later when the network becomes available. Why DTNs are important? 1. Overcoming connectivity issues. DTNs are ideal for places where network coverage is poor or intermittent, like rural areas or disaster zones. 2. Improved communication in challenging environments. DTNs enable communication in harsh environments, such as outer space, deep-sea exploration, or places where there's no stable network. 3. Efficiency. Even with low bandwidth or sporadic connections, DTNs can ensure that data is eventually delivered. Tip to remember. Delay-tolerant networks is equal to data waits until it can be sent. It's like sending a letter through a postal service where it might take time to reach its destination, but it eventually gets there.